This video will demonstrate how to design a double angle welded bolted connection in VAConnect. Let's get started. In this example, we will design double angles welded at the column and bolted to the beam to connect the web of a W16 by 36 to the flange of a W14 by 90 as shown in the detail. This connection will be designed to resist shear from both dead and live loads. Note, double angles welded at the support can be designed to only resist shear loads. According to Part 12 of the AISC Steel Construction Manual, double angle connections with welds on the outstanding legs provide minimal strength to resist axial loads due to the flexural loading that is applied about the longitudinal axis of these welds. Double angle welded bolted connections in VAConnect are designed according to the AISC 360 design specification and Part 10 of the AISC Steel Construction Manual. The welds at the support are designed to resist the eccentric shear loads using the Instantaneous Center of Rotation method to determine the eccentric weld group capacity. The C coefficients for eccentrically loaded weld groups are included in the detailed reports. In accordance with the AISC Construction Manual Part 10, the eccentricity on the supported side of the double angles, that is the beam side, is neglected when a single vertical row of bolts through the beam does not exceed a distance of 3 inches from the face of the support. When this condition is not met, VAConnect accounts for eccentricity using the Instantaneous Center of Rotation method to determine the eccentric bolt group capacity for shear, bearing, and tearout at the beam side of the double angle and at the web of the beam. The C coefficient for eccentrically loaded weld groups is included in the detailed reports. Note, VAConnect assumes that the pin, which allows for rotational ductility, occurs at the face of the support. Therefore, eccentricity at the faying surface of the double angles and the support is not considered. We will start out in VAConnect by adjusting the geometry of the connection. Selecting the beam, a W16 by 36 will be chosen from the shape database. Next, we will adjust the thickness of the support to equal the flange thickness of the W14 by 90 column. Selecting the double angles shows that 2 4 by 3.5 by 1/4 inch angles are used by default. Let's adjust the number of bolt rows to 3 and slightly increase the eccentricity of the bolt group. Now we can move on to applying loads to the connection. We will enter values for shear in the dead load case and shear in the live load case. With the surface level loads defined, we can go to the Load Case Manager and select which building code we want to use for the load combinations, which are automatically implemented. Now with the loads and load combinations specified for the connection, we can turn our attention to the project status to see all the limit states that are automatically checked. Immediately, we see that several limit states are failing. The double angles are failing in shear yield, shear rupture, and block shear. Also, the bolt group capacity of the beam is failing, which is controlled by bolt bearing. Additionally, the weld and base metal check at the double angles are failing. First thing we'll do is add another row of bolts, which resolves the bolt bearing failure at the web. This also lengthens the angles, giving them more capacity, and resolves the various failing limit states for the double angles. Now, only the welds at the support are failing. Clicking on the fillet weld check at the support, we see that the eccentricity on the welds is 4 inches, which is the angle leg length at the support. Reducing the leg length should reduce the demand on the welds. If we reduce the length to a value less than 3 inches, however, the connection detailing fails since we are less than the 3-inch limit allowed, as discussed in Part 10 of the AISC Manual. We also cannot increase the weld size without exceeding the weld size limitation in the AISC 360 design specification. Therefore, let's choose the option to weld the bottom of the angles, which increases the capacity enough to allow the weld check to pass. Note, while VAConnect allows welding along the bottom of the double angles, it does not allow for welding along the top, as this would inhibit the flexibility and necessary end rotation of the connection. Now all the active limit states for the connection pass, and we have no detailing warnings, meaning that the connection is adequate to support the applied loads. Note, the flexural yield buckling limit state and the flexural rupture limit state for the double angles is currently not checked because eccentricity on the beam side of the connection is neglected since we have a single column of bolts that does not exceed a distance of 3 inches from the face of the support. If, for example, the angles had larger legs and there were 2 columns of bolts, the flexural limit states for the angles would become active, having unity values greater than 0. The flexural demand for this connection is also accounted for in the interaction limit states, which consider combined shear and flexural loads on the legs of the double angles that are connected to the beam. Furthermore, we see that the eccentricity on the bolt groups is now considered using the Instantaneous Center of Rotation method. VAConnect also allows for one or both flanges of the supported beam to be coped if, for example, we wanted to accommodate a welded bolted double angle beam to girder connection as shown in this detail. Also, for this particular connection, we might want to cope just the bottom flange of the beam to avoid field welding of the double angles. The specifics of cope beams are discussed in more details towards the end of the Shear tab training video. With the design complete, we can switch to the report view to easily create a report to document our work. A concise design summary is automatically generated, showing the maximum demand to capacity ratio or unity value for each limit state. Also, information on the model and loads can be included in the report. Detailed reports showing the calculations for each limit state can be added to the report. Finally, summary tables for each limit state can be included in the report to show the values of various parameters for the limit state and show the unity value for each load set and load combination. In just a few minutes, we have used VAConnect to create an optimal design for our double angle welded bolted connection and produced a report to document our work. Thanks for watching and have a great day.